Hey everyone, and welcome. Today we are diving deep into something truly on the cutting edge of AI. We're talking about AI agents. And look, if you think you know AI just because you've used a chatbot, well, get ready because you're about to see the next giant leap forward. So let me kick things off with a quick story that just perfectly captures what makes these agents so special. Picture this, someone's doing a live demo, and an AI agent is given a simple task, do some research online. It gets to work, but then its main search tool just fails. It hits an error. Now, any normal program would just crash, right? Game over. But this agent, it didn't even skip a beat. It recognized the problem on its own, switched to a totally different tool it had, a Wikipedia search, and just finished the job perfectly. So, you gotta ask, how on earth did it do that? That moment, that independent problem-solving moment, is what separates a simple AI tool from a true AI agent. It's not just about responding to a prompt. It's about reasoning, adapting, and taking action. And that really brings us to the core of it. We need to draw a really clear line between the AI that we've all gotten used to and these new, much more powerful autonomous systems. This right here breaks it down perfectly. You see, a standard large language model, your basic chatbot, it works in what you could call one-shot mode. It's like asking someone to write a 5-page essay in one single go. No backspace, no edits, no second thoughts. Pretty impressive, sure, but it's going to have flaws. An AI agent, on the other hand, uses an iterative workflow. It's much more like how a real person would write that essay. First, you plan an outline, then you write a draft, then you actually read it over, find the weak spots, and revise it. That loop, that is the secret sauce. Okay, so how does this whole iterative thing actually work under the hood? Let's go ahead and take a look at the engine that's really driving these agents. The process they follow is actually, well, it's remarkably human. It's a whole multi-step workflow. First, it makes a plan, an outline. Then it asks itself, do I need to go look something up for this? Then it writes a first draft. But, and this is the key, it doesn't stop there. It then reviews its own work, actively looking for what it did wrong. And finally, it revises based on that feedback. It's this constant cycle of self-improvement. To make this even clearer, let's imagine we're building an agent from scratch. The very first thing you're going to need is the brain, and that's the large language model itself. Think something like GPT-4. This is the core engine that does all the reasoning, the decision-making. It's the part that understands the goal and manages the whole process. But a brain by itself can't really do anything in the real world. So the next piece we need is the toolkit. This is what gives the agent its hands and its eyes. The toolkit is basically a collection of tools it can use, things like searching the web, running code, or connecting to other apps. This is how the agent actually gets things done. And last but not least, we give it the playbook. Now, this isn't some rigid set of rules. It's more like its ability to strategize. It's the agent's power to make a plan, to reflect on how it's doing, and to course correct when things go sideways. This is really where that spark of autonomy comes from. Let's just zoom in on that last part for a second, because it's so important. The official term for it is reflection. It's this incredible ability for the agent to basically be its own critic. It looks at what it just made, finds the flaws, and then actively tries to fix them. It's what creates that powerful feedback loop for getting better and better. Let's see this in action. Make it super concrete. Say we ask an agent to write some code. It gives it a shot and produces its first draft, a function we'll just call do task X. Now, a simple chatbot would just hand that over to you and say, here you go. But an agent with reflection, it does something amazing. It essentially has a conversation with itself. It might generate an internal thought that says, whoops, there's a bug on line 5. I should probably fix it by doing this. It finds its own mistake and figures out how to fix it, all without any help from us. And just like that, based on its own internal feedback, it revises the code and spits out a better version, do task V2. And this cycle can happen over and over again, with the agent just tweaking and refining its work until it's really solid. This is what makes them so incredibly powerful. Okay, so if one agent can do all that, what happens when you get a whole team of them working together? Yeah, this is where things go from being really interesting to kind of mind-blowing. We're moving from a single problem solver to a whole collaborative system. And honestly, the best way to think about this is just like a human software team. You can actually create a team of these agents and give them all specialized jobs. You could have one agent be the engineer who just focuses on writing great code. Another agent is the QA tester, whose only job is to try and break that code. And maybe a third acts as the product manager, making sure the final product is actually what the user wanted in the first place.
So why bother doing all this? Well, it's for the exact same reasons that human teams work so well. It enhances focus. Each agent has one job and gets really good at it. It lets you take a massive, complicated problem and break it down into smaller, bite-sized pieces. And almost every time, having these specialized roles leads to a way better final result. You're basically building a tiny, autonomous company to solve your problem.
So let's step back for a second. Where is all of this going? Let's talk about the real-world impact and what the future might look like with this kind of technology.
So the big question is, does this agentic approach actually work in the real world? Or is it just a cool idea? Well, when you look at a really complex field like software development, the answer is a resounding yes. The performance gains we're seeing aren't just little tweaks. They are absolutely dramatic. And we've got the data to prove it. Check this out. On a standard coding test, a regular GPT 3.5 model got it right about 48% of the time, which, hey, is not bad. But when you take that exact same model and put it inside one of these agent workflows, letting it plan, code, test, and revise its own work, that correctness rate just skyrockets to over 95%. That's not just a small improvement. That is a complete and total game changer.
And really, that's the power we're starting to unlock here. We're moving from an AI that just gives you answers to an AI that can actually accomplish goals. But of course, this incredible new level of autonomy brings up a huge question for all of us. As these agents get smarter, more capable, and more independent, how do we make sure their goals and their actions always stay aligned with ours? That right there is the great challenge and the great opportunity that's waiting for us.